Electricity is all around us, powering technology like our cell phones, computers, lights, soldering irons, and air conditioners. It's tough to escape it in our modern world. Even when you try to escape electricity, it's still at work throughout nature, from the lightning in a thunderstorm to the synapses inside our body. But what exactly is electricity? In this tutorial we will focus on current electricity, the stuff that powers our electric gadgets. So let's get started! Alright, so the electricity is briefly defined as the flow of electric charge. But there's so much behind this simple statement. Where do the charges come from? How do we move them? Where do they move to? How does electric charge cause mechanical motion or make things light up? So many questions. So to begin to explain what electricity is, we need to zoom way in beyond the matter and molecules to the atoms that make up everything we interact with in life. To understand the fundamentals of electricity, we need to begin by focusing in on atoms, one of the basic building blocks of life and matter. Atoms exist in over 100 different forms as chemical elements like hydrogen, carbon, oxygen, and copper. Atoms of many types can combine to make molecules, which build the matter we can physically see and touch. Atoms are tiny, stretching at a max to about 300 picometers long. Even though they are so small, they are not small enough to explain the working of electricity. We need to dive down one more level and look in on the building blocks of atoms, which are protons, neutrons, and electrons. So an atom is built with a combination of three distinct particles: electrons, protons, and neutrons. Each atom has a center nucleus where the protons and neutrons are densely packed together. Surrounding the nucleus are a group of orbiting electrons. Every atom must have at least one proton in it. The number of protons in an atom is important because it defines what chemical element the atom represents. So for example, an atom with just one proton is hydrogen, an atom with 29 protons is copper, and an atom with 94 protons is plutonium. This count of protons is called the atom's atomic number. As in the Bohr atom model, a nucleus with 29 protons, making it a copper atom, is surrounded by an equal number of electrons. The atom's electrons aren't all forever bound to the atom. The electrons on the outer orbit of the atom are called valence electrons. With enough outside force, a valence electron can escape orbit of the atom and become free. Free electrons allow us to move charge, which is what electricity is all about. We usually use copper cables to form the circuit because the atoms that make copper have a loosely bound electron in their outermost or valence shell, which is free to move around inside the metal. And this free electron is very easy to move, which is why copper is so popular. For us to make use of this, we need lots of electrons to flow in the same direction along the circuit. We can then place things such as lamps in the way of these electrons so that they flow through it and generate light and heat, etc. To do this, we need to force the electrons to move, and we can do that by applying a voltage. Voltage is the motivation, a pushing force. It's like a pressure in a water pipe. The more pressure we have, the more water can flow. The more voltage we have, the more electrons can flow. So we need a lot of electrons to flow along a circuit and through our lamps to get them to shine brightly. However, the cables and lamp can only handle a certain amount of electrons passing through them. People often refer to rivers having a strong current. It's very similar to electricity. A river with a lot of fast flowing water is said to have a strong current. The same with electricity. A cable with a lot of electrons flowing also has a high current. A river is able to handle a certain amount of water flowing through it, but if more water enters than it can handle, then the river will burst its banks. The same with electricity, the cable will burst and burn out. Therefore, manufacturers need to be able to test cables and lamps to find out how much current they can handle. We also want to be able to see how much current is flowing through our circuit, as well as being able to calculate this. So how to measure the current in a circuit? Or how to measure the voltage across a component? Well, in the next course, we will find it out.